changing. Natural resources are running out. Biodiversity is collapsing. Our house is on fire. We all know it. Everyone's talking about it. Now we must act. Practical, high-impact solutions already exist. Now more than ever, we need industrial players to accelerate their rollout. But other problems remain to be solved. We must do all we can to invent the solutions of tomorrow. We must go beyond transition. There is no time left for gradually changing our methods. To reconcile the environment and human development, we must make decisive, difficult choices. That is why Veolia aspires to a larger, higher, more challenging ambition: ecological transformation. Ecological transformation means genuinely adapting our patterns of production and consumption. It means placing ecology at the heart of every process, every assessment, every decision. It means developing radical, meaningful solutions to meet humanity's existential challenges, decarbonizing industry to combat climate warming, promoting the circular economy to combat resource depletion, decontaminating the air, water and soil, protecting biodiversity, and creating more resource-efficient agriculture. None of this would be possible without the coordinated action of all our stakeholders, our dedicated employees, but also our customers, our shareholders, our partners, and wider society as a whole. We are committed to delivering expert-led change and convinced that economic, social, and environmental concerns must form an indivisible whole. Decontaminating, sanitizing, purifying, recycling, recovering, conserving, and facilitating access to resources. Veolia has always worked to create solutions capable of building a better, more sustainable future for all. Today, we want to become the benchmark company for ecological transformation. Our ambition is huge, but so is our determination. Ecological transformation, that is our purpose.
It's quite a hard-hitting start, quite a big picture. And if we start to bring that into the reasons why we're working on what we're working on, we look at climate change as the biggest impact here. And we think about the UK particularly. It might not feel like it may today, actually. Nice and warm today, really great weather. But actually, it's been one of the warmest springs on record. It hasn't felt like that over the last few weeks because of climate change and the impacts to the high-level climates. We've seen actually one of the wettest springs, but equally one of the coldest springs because of the cloud cover in the UK. So those impacts are being felt of global climate change. And they're being felt both through us, through weather, but also then impacts on the businesses that we work with. This is really important, this kind of scene setting for us. We think about global supply chains. We think about how our customers are going to be impacted by how they're going to be impacted across their supply chain. So I think some of the big picture numbers that we see on the slide here, the one that sticks out to me is security of supply and logistics. These are huge parts of our global supply chain, particularly in grocery retail, where we're seeing global supply chains get impacted by being able to move product, material and food across countries. We're seeing this as a real problem, and we're trying to focus on how we can support these changes. So what Veolia does, we focus on three areas: water, waste and energy in simple terms. And we focus across the globe purposely because we understand that global supply chains are impacted everywhere. A lot of our focus in the UK then is actually on some of these smaller projects that we can do. We focus on waste management, we focus on resource management, we focus on recycling. We also then focus on energy and how we can produce energy and feed it back through a circular route into our customers, into our homes. We also focus on water, how we can desanitize and depollute water and reuse it within the supply chains. I'm moving a little bit of pace with this, but I want to kind of bring those scenes to life that actually resource management and ecological transformation covers everything that we touch within our supply chains. I'm going to pass over to Luther in a second because he's going to talk to us about actually what happens in the UK. We see the big picture there, we see global supply chains, we see the impacts of climate change. But actually we now need to think about how do we, as a business, support our customers and support the wider UK economy in actually dealing with materials that we can get our hands on. Luther.
Thanks, Andy. Hi everyone, so I'm going to talk about and unpack a little bit the UK recycling infrastructure and how that landscape looks like. So what I've put on the slides up here is actually a materials recycling facility. So what it covers is the complex process steps that actually sort the different types of waste materials that are produced across the market within the UK. So currently there are over 100 different materials recycling facilities in the UK. And these material recycling facilities process everything, including waste, paper and cardboard, glass, metals, as well as other materials as well. It is estimated that by 2030, that the number of tons processed by materials recycling facilities will reach 5 million tons annually. However, at present, it's around 4.2 million tons. So up here is actually sorted fibre, so what it looks like after the materials recycling process. Currently in the UK, there isn't a huge demand for sorted fibre. As a result, this sorted fibre is actually, post the materials recycling facility, shipped towards the Far East, and this is a common trend across the waste sector. Moving on, we have a pulping process. So this is a typical process that is used to actually reprocess recycled paper and recycled cardboard into recycled pulp, as well as ink waste in terms of liquid form, and an additional byproduct to the process. So, sorted mixed plastics. In terms of the landscape in the UK, it's a little bit more promising in regards to the infrastructure that is present within the UK. This can be seen in terms of investment into PET recycling facilities and reprocessing facilities at hand, as well as HDPE recycling and reprocessing facilities. In terms of reprocessing capability, like I said, the UK demonstrates a lot more capability as opposed to sorted fibre. However, mainland Europe demonstrates a more superior capability towards reprocessing this material, and therefore export is expected in this regard. So up here we can see a facility, and this is used to actually reprocess the likes of PET plastics as well as HDPE plastics. An additional pre-sort is used to actually sort out metals that is considered a contaminant in regards to this process. And as mentioned, this is something that is commonly used within the UK, particularly with Veolia at its current facility in Rainham. So, regarding waste, there's typically 3 disposal points or 3 end destinations regarding waste following collection. The first is actually recycling, the second is recovery, and the third is disposal. Earlier within the presentation, we talked about materials recycling facilities. This is typically the recycling part of this diagram on the waste hierarchy. In terms of recovery, this is what happens when waste is sent to energy from waste, as well as incineration. And lastly, disposal. This is where waste is sent for landfill. So, materials recycling facilities, their aim is to maximize the amount of material sent for reprocessing in the aforementioned facilities that I talked about in the beginning of this presentation. However, there is a residue stream within the materials recycling facilities for material that is not favorably sorted, and it's this residue stream that is sent for incineration. This can be for a number of reasons, due to contamination or down to their fundamental product design. So, for materials that are actually favorably sorted, they are sent from the materials recycling facility in baled form to further reprocessing facilities and are further processed for additional application and a second life. So, what's happening now and next? So, in terms of actually increasing recycling, chemical recycling represents a huge opportunity to increase the recycling rates within the UK. What does this consist of? It consists of actually taking chemical, or rather plastic products, and reverting them back to their chemical feedstocks as well as their fundamental raw materials. This is an important technology, like I said, to increase recycling rates ahead of targets that are incoming in terms of legislative changes. So the second bit of technology I'm going to talk about is actually plastics recycling. So this can be anything such as PET recycling facilities, as well as HDPE recycling facilities. These will provide the input materials for recycled content in terms of targets that are required for PET bottles and HDPE bottles. And as you can see, the process steps here on the slide. So I'm going to hand over to Andy to talk about the legislation and the circular economy as well, and how that relates.
Thanks, Luther. So what was really important about that little few slides there is that the UK infrastructure is actually quite limited. Lots of the challenges that we have is that we have to export a huge amount of materials. So getting the right products into our facilities and being able to extract value from them is key. One of the other things that's driving what we're doing with materials is legislation. It was touched on earlier, and I'm going to bring up what is classed as the slide of doom. And it's called that because it's packed. Okay, so this is legislation that is impacting waste and recycling and the resource and waste strategy. And it covers everything. It covers packaging, it covers food waste, it covers collections. It goes all the way through to 2028 and into 2030 when we see even impacts on vehicle choices. So all of these pieces of legislation are coming in over the next few years, and they're coming at pace. And it's really important to kind of focus on some of these because they impact all of our supply chains. So not only have we got what we started with climate change impacting supply chains, we've now got legislation and all of the changes that we need to make here. So just to pick out a few of these, we've talked earlier about EPR, we talked earlier about DRS, when they may come in and the impacts they'll have on choices we make around packaging. But one of the key ones that I wanted to pick up on is over to the right here, that side, yes, this side, is something called ETS, which is the Emissions Trading Scheme. Now, that's already in place for certain industries. That's going to become key to the waste industry kind of late 2028. What that's going to do is add a tax to the emissions that come out of energy recovery facilities. So we're now talking about EPR and DRS focusing on recyclable materials. We've now got taxes coming through that are going to focus on non-recyclable materials, particularly those that are fossil fuel-based, organic or textile. So it's so key for us now to act and to think about designing out those type of materials, polymers and organics and textiles out of products that can't be recycled. So these are multi-layer materials, multi-layer products. Is massively key because when this kicks in, there's going to be a huge financial challenge as well. We can't calculate it yet because they haven't told us how to, but when we get there, we're going to see huge impacts and it's going to be hundreds of pounds per tonne of CO2 emission. So that's why this is our slide of doom, because it's really quite a big picture and really coming at pace. But what we're doing, we're doing things about it. We're thinking about the circular economy. This is a graphic that many of you may have seen from the Ellen MacArthur Foundation. And it's really key. I'm going to read what it says, because it's key to think about products that circulate in either the biological or technical cycle. It's essential they've been designed with their eventual circulation in mind. And it's been brilliant today to hear examples of some of those products already. But this is so important that where we sit, and Luther's mentioned it as well, where we sit in the value chain, if products are making their way to incineration for us to simply create energy from, we've missed the opportunity to bring them back into the circular economy. I want to touch on a couple of examples now of how we've supported businesses in taking the right steps to build up into this circular economy. The first one is with McDonald's, a very well-known global brand. They approached us and they asked us the question about their single-use plastics within their supply chain. They asked us to do some evaluation. So we worked across their supply chain to provide a RAG status on all single-use plastic items within their supply chain, allowing them to think about the green items that are highly recyclable. They're the ones that we want. They're the ones that can be recycled in both municipal, so household and commercial locations. Thinking about the amber ones, the ones that have recyclability, but they've got specific considerations, i.e. they may have to go through a specific process. And the red ones, the ones that are non-recyclable. This allowed McDonald's then to take the right steps with their supply chain partners to identify those problem items and start to manage those out. So this is the kind of program that Veolia can bring in to our customer bases to ensure that they can understand how to design for recycling and identify those challenging materials. Luther's going to come back on and he's going to talk about another specific item that we've worked with, which I think is a great case study.
So, we've talked about the challenges, we've talked about the UK landscape in terms of infrastructure, and we talked about circular economy and incoming legislation, as well as excellent examples from Andy discussing the work that we're actually currently doing with our customers. So I'm going to discuss a specific example carried out by the CircPack department within Veolia, and this actually tackles a very key iconic packaging, as you can see on the screen here, the Pringles tube. And as mentioned, like I said, it's very iconic, highly recognizable. It has great customer preference, as I'm sure you all know. And it's got extremely great properties due to its eclectic nature. And this actually provides a extended shelf life as well as protecting the product within inside. However, due to this packaging being a number of sort of different materials, being a multi-material tube at hand, which shows actually a PP cap, a metal end, fiber-based tube, and inside lamination of PE, and as well as aluminium film. This is a nightmare when it comes to materials recycling facilities, due to the fact that the complex material natures will be detected by the different technologies within the materials recycling facilities. So, the challenge at hand was actually to see what we can do with Pringles to ensure that that said product and said packaging can be more recyclable and produce higher recycling rates. So the challenge at hand, like I said, production lines for established packaging that are on the market are already efficient, they're already established. Design changes could actually cause quality issues in terms of potentially actually reducing the shelf life of the product contained within. To change anything in regards to one of the product components would require significant investment in terms of the production line and the production lines that are present across multiple geographies. And then an additional challenge at hand as well is the fragmentation in terms of EPR, sorting and recycling across different countries in mainland Europe as well as the UK. So the solution, it's not all doom and gloom. We've managed to actually work with and work well with Pringles in this regard, actually, to actually develop a solution that actually increases the amount of fiber contained with its current packaging. So the previous packaging actually had below 80% paper and fiber content as a whole. And at this current level, it's got 90%. And one of the key fundamental changes that we worked with Pringles to achieve was actually substituting the metal end for a paper end. So as mentioned, this was carried out by our department CircPack by Veolia, and the whole schematic of work consisted of leveraging our theoretical knowledge in terms of recycling technologies, as I've discussed throughout this presentation, recycling infrastructure within the UK and across the world, as well as our understanding on the relevant process steps inside the materials recycling facility and what materials are removed at different points. As you can see, steel, beverage cartons, aluminium are removed predominantly at the beginning, followed by plastics towards the end of the materials recycling facility process. And when I say removed and sorted and baled towards being sent to reprocessing facilities. In addition, we leveraged our operational know-how by conducting full sorting tests across 3 different countries. And sorting tests are actually consist of running the packaging throughout, or rather the packaging samples throughout the materials recycling facilities at hand, and measuring the performance of where that packaging is sorted. We use innovative technologies such as RFID tags to determine the location, to take this level of assessment to another height. Furthermore, we conducted a sorting test by actually changing the near-infrared scanners within the materials recycling facilities to simulate different scenarios. Near-infrared scanners are actually used for detection of plastics, beverage cartons, and other types of materials. And lastly, we conducted pulping tests with the newly designed packaging to see how it actually performs in the reprocessing end of the supply chain. Furthermore, we explored a number of different creative solutions. As mentioned, we substituted the metal end for a sort of paper end, and we also actually trialed a metal tube in place of the fiber tube. And then furthermore, we actually conducted other analysis, such as country mapping in regards to EPR and other types of legislation, and provided strategic advice. So wrapping up on this case study at hand, sort of some of the key messages that I want to communicate to you all today. Pringles represents a company that was committed to taking action, and I truly commend them for this act. Rollout, however, in terms of changes, takes a significant amount of time just due to how complex our supply chains have developed. It requires innovative thinking, and it requires a level of investment to achieve desired goals. Sorting trials throughout this process had actually proved that Pringles cans can actually be sorted within the fiber bales and actually sent for reprocessing within pulping. And as the industry moves forward, technological advancements such as robotics, machine learning, as well as digital watermarks will actually increase the amount of recovery for said target materials as we move forward.
Thanks, Luther. So just a quick summary on what we've talked about here. I think it's obvious we need to act with urgency. We can see the ecological impacts, but also the legislative pressures that are being applied across kind of packaging and supply chains. That's really obvious, that's really important. And I think with that one, the word collaboration was key as well. That does come up in a few of the presentations. I think that we need to collaborate across the whole of supply chains. Retailers can't fix problems, we can't fix problems, designers can't fix problems unless we're all working together and understanding every part of that chain. I think we need to think about that supply chain as a circular opportunity. Designing for recycling is key, and that leads us on that last one. I think the big ask for everybody in the room is to really reflect, review design guidelines, think about products, ensure they can support recycling and circularity. Thank you all.
Thank you.